Okay. Ready? Okay, we have, again, we're going to deal with inverse functions. And again, graphically, when two functions are inverses of each other, the graphs will be what? Reflections over the what? Over the line y equals x, right? And so as a result, if f of x contains the point AB, won't f inverse contain the point BA? Isn't that what happens with inverse functions? You just switch the domain and range. You switch the x and y values. And so, for example, that's another way of saying you have the point 2, 3 on f, right? Yes? And therefore, you'd have the value f inverse of 3 equals 2. In other words, you'd have the point 3 comma 2 on the graph of f inverse. Are you with me on that? You see how I can write it that way? Get used to that. Because if you don't get used to that, then this is going to make no sense down here. Okay? Okay, now, furthermore, the following statements about the slopes or derivatives will also be true. The slope or derivative value on the graph of f at the point AB will be the reciprocal of the slope or derivative value of the graph of f inverse at the point BA. In other words, to find f prime of A, you can just take the reciprocal of, in other words, 1 over f inverse prime of B. And by the way, it works the other way as well. You can find f inverse prime of B by taking the reciprocal of, in other words, 1 over f prime of A. Now, again, I think it'll make a little more sense if you look at it graphically. So, I don't know, suppose this is what f looks like, okay? And suppose, I don't know, this is the point 5 comma 2 or whatever, okay? Okay, so clearly then you have what? F of 5 equals what? 2. You with me on that? Okay, again, this is going to make more sense if you understand what I'm showing you here, okay? Now, again, from algebra, you remember that to get the inverse of that function, graphically, you can just flip this graph over the line y equals x, right? And so then it'll end up looking something like this, right? Yes, something like that? Okay, and what is that? That's the graph of what? F. What? F inverse, isn't it? And by the way, if you had the point 5 comma 2 on this, that'll switch up here to the point what? 2 comma what? 5. Are you following me, guys? In other words, you'll have what? F inverse of 2 equals what? Equals 5. Are you following me on this? So again, all I have is the point, for example, 5, 2 on f, which would correspond to the point 2, 5 on f inverse. And that's how we would write it, using function notation, right? Okay, now, here's where the calculus comes in. Ready? If I look at the tangent line there, and again, just suppose the slope is, I don't know, maybe 3/4, whatever, yeah, 3/4 for example, okay? So how would you write that, the fact that that's slope there is 3/4? How would you write that? You'd write what? F prime of what? F prime of what? 5 equals what? 3/4. You with me on that? Yes? Okay, and then, well, when everything gets flipped, that tangent line gets flipped as well. So guess what the slope of that tangent line would be? Remember, you're just switching the x and y values, right? And so what would that slope be? What would that slope be? I only hear one person saying it. What would it be? Everybody agree that would be 4/3 there? Yes? If the x and y's get flipped, everything gets flipped when you reflect the graph of f over that line y equals x, okay? And how would you write that, by the way? You'd write what? F inverse prime of 2. That's just how we write it. We put that extra set of parentheses just so that and that don't get mixed up. You with me? So you can say F inverse prime of 2 equals what? 4/3. Are you following me on that? And again, here's another way to look at it. If you want to find F inverse prime of 2, what you'd take the reciprocal of, in other words, 1 over F prime of 5, wouldn't you? So in other words, you'd take what? 1 over 3/4, which gives you what? 4/3. So that's another way of looking at it. Are you with me on this, guys? And you could do it the other way as well. You can say f prime of 5 is 1 over f inverse prime of 2, right? Which is 1 over 4/3, which is what? Which is what? 3/4, okay? Any questions on that? Does this make sense? So again, if you understand this and visualize this, then you really don't have to memorize this formula here. It'll be common sense, won't it? If you think about it, instead of just trying to memorize it, if you think about it, you should know it now from here on out. Is that clear? Yes? Again, don't try and memorize things. Think about where they come from and you'll remember them. Okay. All right, so there's the first concept. So let's do a couple examples of this. Suppose I tell you that f prime of 3 is 5/7. Okay. All right. Try not to take that long, especially when you take it at the beginning of the hour. Okay. Okay. So you got f prime of 3 equals 5/7. Okay. Suppose at the point 3,6 on f, and you want to find the slope of the curve at the point 6,3 on the inverse of f. In other words, you want to find f inverse prime of 6 is another way of looking at that, right? When I say find that, you're going to be finding f inverse prime of 6, right? Okay, well, again, if you think about it, to find f inverse prime of 6, wouldn't you take the reciprocal of, in other words, 1 over f prime of 3, right? And so if that's 5/7, you take 1 over 5/7, which gives you 7/5. Okay? Yes?
When we're also doing the book homework, could we just say when we're taking the inverse of the derivative, to put it to the negative first power instead? Because you're doing the same thing.
Wait, say it again?
When you're taking the inverse of a derivative, can't you just take the other, can't you just raise the other derivative to the negative first power?
Okay, it's not. It's not this, you're not raising it to the negative first power. I know what you're thinking. But I wouldn't look at it like that. I know what you're thinking, but I wouldn't look at it that way. Okay, just be careful. Okay? Because you're taking the derivative of the inverse, kind of not the other way around, right? Yeah. Okay. All right. Okay. So now look. Again, I'm going to put a bunch of stars by this problem, and then I'm going to see how many people get it wrong in the next test, which will tell me you didn't study your notes enough. Okay? I'm doing one of these. I think you have 1 or 2 on your homework, and I know there's 1 on the test for sure, at least 1, maybe 2. So again, watch what I'm going to do here. Okay, ready? Okay, so I'm giving you that as f, and I want to find the value of f inverse prime of 3. Okay, and so okay, so the fact that you're asked to find f inverse prime of 3, just the fact that you're asked to find that means you're talking about the point 3 something on f inverse. Everybody agree with me on that? Just because that's what I'm asking you to find, right? I'm asking you to find f inverse prime of 3. So you're talking about you have the point 3 something on f inverse, which would correspond to the point something 3 on f. Any questions on that? Are you following me? Is that okay? Again, that's an x value, isn't it? And so you're talking about, we're looking at the point 3 something on f inverse, because I'm asking you to find f inverse prime of 3, right? No, I'm asking you to find f inverse prime of 3. That's clearly an x value on f inverse, right? You have the point 3 something on f inverse because I'm asking you to find f inverse prime of 3. And so that would correspond to the point something 3 on f. Are you with me? Okay? Now, so what you need to do here then is take f of x, which is this, and again, this is a y value on f, isn't it? So put a 3 there. Okay. Now, I mean, you could move the 3 to the other side and try and solve it algebraically, but I don't think you're going to be able to do that. It's not going to work. And so another way to solve and find x here is to solve this equation by graphing on a calculator, which you should all know how to do. Okay? You simply put one at the side of the equation in y1, put the other side of the equation in y2. Okay? And if you graph these two equations and find out where they intersect, that'll be one way to solve this equation for x, right? Okay. So here we go. I'm just going to start by hitting Zoom Z standard. I'll change the window if I need to. I don't think I'm going to need to do that. And so I can just do second trace intersect now. Enter, enter, enter. So it looks like x is what? 2, right? Make sense, guys? Yes? Okay. And so what that means is we have the point 2, 3 on f, which would now correspond to the point what? 3, 2 on f inverse, right? Following me? Yes? Any questions so far? Okay, now, according to what I just went over a few minutes ago, to find f inverse prime of 3, wouldn't we take the reciprocal of, in other words, 1 over f prime of what? F prime of what? 2, right? The slopes at these 2 points are flipped, right? Makes sense? Any questions so far? Okay, now at this point, how do I find f prime of 2? Well, that should be pretty easy. If this is f of x, what's f prime of x? What's f prime of x? What's the derivative of that, guys? Plus 1. And so if you plug a 2 in there, you get what, 4? Is that right? And so this will be 1 over 4, which is just 1/4. And again, I don't think the one on the test works out this nicely, but doesn't matter. Even if it's decimals, you should be able to handle it, right? Is that okay? So even if it's decimals, you should be able to handle it. It's the same procedure, even if it doesn't work out to a whole number, right? Again, yes, there's a 100% chance that that'll show up at least once or twice on the next test, so be ready for it. All right? Okay? All right, so we're done with concept number 1 for the day. Now we're moving on to the second concept. And second concept is on higher derivatives, okay? All right, so we can talk about the second derivative as just putting, right, f double prime of x, right, which is simply the derivative of f prime, right? Then we can talk about the third derivative as being f triple prime of x, which again would be just the derivative of f prime, or f double prime, I should say, right? Following me? Now anything higher than 3, instead of continuing the notation like that, at that point we just put a 4 in parentheses. And again, you know, the fifth derivative would look like that. Please put the parentheses, because if I left the parentheses out there, that would mean something else. If I left the parentheses out, that means I would take f of x and raise it to the 4th power. That's not what I'm doing here, am I? No, that 4 in parentheses actually stands for what? The 4th derivative. Okay, that is not the same thing as taking f of x and raising the function to the 4th power. That's clearly not the same thing, is it? No. So don't make that mistake, okay? So if you're going to write the derivatives like that, make sure you put the 4 or the 5 or the 6 or whatever in parentheses to indicate derivative. Okay, guys? Good? Okay, so real quick then. If that's f of x, then you just take the derivative of that to get f prime. Take the derivative of that to get f double prime. Take the derivative of that to get f triple prime. And then what's the derivative of 6? 0. And then what's the derivative of 0? 0. So any derivative from here on out will be 0. Agreed? Okay? All right. Now here, okay. All right. So let me have you guys help me here. Ready? All right. How about, I don't know, Parth? If I want to find the first derivative of y prime, what will I need to do here? I'll need to do what? Okay, so derivative of the first, which is 1, yep. Okay. Okay, good. So he used the product rule, as he should have. Everybody agree you have to use the product rule there? Okay, to get the first derivative and then simplify it. Okay, and now I want to find the second derivative, and I'll have somebody help me there. How about, I don't know. How about Samia? What do you think? What do I need to do to find the second derivative? Okay, good. Okay, and so you got to use a product rule here, and so what I'm going to do is, when I use a product rule, I'm going to put it in parentheses, right? So I remember to distribute the negative later, or the minus. Okay, so. Okay. Okay, good. Okay, everybody agrees she used the product rule there to get that. And then we're going to simply distribute the subtraction. And I can combine these now, right, because they're like terms. Okay, good. Thank you. All right, so there's the second derivative. Any questions on that? Good? Okay? Yes? All right. Everybody with me? Yeah? Okay. All right, so that takes care of the first page. Okay, all right, now we're going to move into some applications. Ready? We've already learned that the velocity is a derivative or slope of the position function, right? In other words, we can write v of t as s prime of t, right? You already know that. What's new now is we're going to add the fact that the acceleration of a moving object is a derivative or slope of the velocity. Okay, in other words, we can write a of t for acceleration, so the acceleration function a of t can be found by differentiating the velocity function, right? And by the way, that's the same thing as saying it's the what? Second derivative of the what? Position. Same thing, right? Same thing? Okay, think of acceleration as the rate at which the velocity is changing. And that'll help us decide if a moving object's rate of movement is increasing or decreasing. Okay? And that'll tell us whether the object is slowing down or speeding up, won't it? Right? Okay? Okay, important notes about velocity. Okay? If an object's acceleration is positive, then the velocity is increasing, right? Make sense? If an object's acceleration is negative, then its velocity is decreasing. Okay, so with that in mind, we're going to now add to this. Now this is going to be very, very, very tricky, and I'm going to try and explain it in a way where, you know, hopefully it'll make sense instead of trying to just memorize all this, because that'd be a lot to just memorize without understanding it. Okay, and we don't want you doing that anyway. So, remembering the fact that the speed is the absolute value of velocity, we can now say the following four things. Ready? If the object's velocity is positive and the acceleration is positive at some moment in time, right, or on an interval, then its speed will be what? Increasing. If the velocity is positive, but the acceleration is negative, then the speed will be decreasing. If the object's velocity is negative and acceleration is positive, then its speed is decreasing. And finally, if the object's velocity is negative and acceleration is negative, then its speed will actually be increasing. Now again, you're not going to be able to just memorize them, and I don't want you to do that anyway. So let's talk about a couple of these individually. Are you ready? And then maybe it'll make more sense. Ready? Okay, let's pick one here. Let's pick number 3. Okay, let's talk about number 3. Ready? Okay, the velocity is negative and the acceleration is positive, right? With me? Okay. Okay. And what do we say? When the acceleration is positive, the what? The velocity will be what? Increasing. That's no different from saying when f prime is positive, f is increasing. Isn't that the same type argument, isn't it? Yes? Okay, because the velocity is the derivative of acceleration, right? I'm sorry, let me say that again. The acceleration is a derivative of velocity. So again, saying acceleration is positive is like saying f prime is positive. And when f prime is positive, the original function f is increasing, right? So in this case, velocity is increasing. Are you with me on that? So again, back to number 3 now. So if the velocity is negative, what will that tell you? That the what? Well, we'll come back to that. If the acceleration is negative, what does that tell you about the velocity? That tells you what? That the velocity is what? Is what? Decreasing. Okay. All right, so this is what we have so far with number 3, right? Knowing that the velocity is negative and the acceleration is, acceleration is what? I wrote it wrong. Acceleration is what? Positive, so the velocity is what? Increasing. Sorry about that. Okay, now, does this make more sense? Okay, so again, we got a negative velocity, we got a positive acceleration, and anytime the acceleration is positive, we can say that the velocity is increasing. Okay, so what we have now is this. We have velocities that's negative and velocity that's increasing. So the best way to demonstrate this is just look at an interval. But, you know, I mean, whatever happens on an interval, you can say is the same thing that's happening at one point on the interval, right? And so, watch this. So if you got velocities that are negative and increasing, okay, think about that. Aren't those velocities that are negative and increasing? Think about the number line, right? Aren't those increasing on a number line? Yes? And what happens when you take the absolute value of those to get the speed? The speed is the absolute value of velocity, isn't it? So what happens when you take the absolute value of those? You get what? 6, 5, 4, 3, and so on. So the speed is what? Decreasing. And so sure enough, isn't that what we said here? Speed is decreasing there. Yes? Okay, so again, instead of trying to memorize those, just take them on a case-by-case basis. Think about it, and you'll have your answer without trying to memorize it. Okay? Sam, please stay with me. Okay? Good or not? Does this make sense? So again, don't try and memorize those. You won't do it. You're not going to be able to memorize those. And even if you did memorize them, they wouldn't make any sense. And so I'd rather you just think about it like this on a case-by-case basis. Can you handle that or not? Yes? Okay. All right. So let's look at this. It should be A, B, C, but whatever. Okay. So let's do an example here. The position of a particle is given by this, where S is in feet and T is in seconds. Find the velocity v sub t and the acceleration function a of t. Ready? Okay, so here we go. All right, so how about Erica? Can you tell me what the velocity function is for that? It's just the derivative, right, of the position? So what do you get?
3t squared minus 12t.
Okay, good. And then how about James? Can you tell me what the acceleration function is?
6t minus 12.
Okay, good. All right, now for part B, I want to use a calculator to graph the acceleration function. So let's do that. And by the way, once I graph it by hitting Zoom Z standard, I only want to look at the interval, what, 0 to 5 it says, right? And then use the graph to find the value of t for which the velocity is increasing and the values of t for which the velocity is decreasing. Okay, and so, all right, so it looks like from 0 to here, you have a what? You have a negative acceleration, which means the velocity is what? Decreasing, right? And then from here to 5, you have a positive acceleration, which means the velocity is what? Increasing. And by the way, I could find that x-intercept, but you can just look at that and tell me the x-intercept is what? 2. It looks like 2, and clearly it is 2, isn't it? So I don't have to use a calculator to find that x-intercept. Clearly it's 2, right? And so the velocity will be increasing from what? It'll be decreasing from 0 to what? 0 to 2. Including 0 or not including 0? Including 0, because clearly at 0 you got a negative velocity over here, don't you? Right? But at 2, the velocity is not negative, so you don't put an equal sign there. And then clearly velocity is increasing whenever acceleration is positive, and so that would be from 2 to 5, wouldn't it? Including what?
5.
Including 5. Everybody good with this? Okay, again, you'll have to do this on the next test. Again, when I tell you something like that exactly is going to show up on the next test, you know it's going to. Exactly like it. Okay? Okay, now, it says find the velocity and the acceleration at time equals 1.8 seconds, and then use them to decide if the particle speed is increasing or decreasing. Okay, so here we go. Ready? Okay, so to find v of 1.8, I'm just going to do this. Sorry. Whoa, what happened? Oh, there we go. Okay. All right. Let me just make sure. Ooh. Oh man. Squared, not cubed, right? So actually, yeah, that's right. That's a 2, right? Did I do the rest of it right? Yes? Okay. So actually it's negative 2.88, right? What per what, guys? What are the units on this? What are the units? What? Feet per second. Okay. All right, then find the acceleration. That's easy. What are the units on that, guys? What are the units there? Feet per second, right? Isn't it feet per second, which you can just write as feet per second squared if you want? Okay, so now we want to know whether the whether the speed, not the velocity, whether the speed is increasing or decreasing. Okay, so again, even though we're only talking about one moment in time, it's easier to analyze what's happening if you think about it on an interval. Okay, the same situation. So again, what do you have here? You have a negative what? Negative velocity and a negative acceleration. Are you following me? So let's think about that. Since A is negative, that tells you what? The velocity is what? The acceleration is negative, the velocity is what? Is what? Decreasing. Yes? Okay, so we have the fact that the velocity is decreasing, and we have what? That the velocity is what? Negative. Okay, so let's think about it. The velocity is decreasing, and the velocity is negative. So let's analyze that. Again, even though this is at one moment in time, we can understand it better if we look at it on an interval. So if the velocity is decreasing, okay, and it's negative, right? So let's draw, or at least write down some values where that would be the case, where the velocity is negative and decreasing, okay? Everybody agree those are negative values that are decreasing on a number line? What happens when we take the absolute value of those to look at the speeds? The speed actually what? Increases. Okay? So you guys got to be right on top of things here, right? Yes. Yeah, I don't know. It'll be very similar. I know that. I don't know. Okay. With me? Yes? Okay. Lauren, did you run off your notes on green paper? No. Okay, you want to put that away for me? Thank you. Okay. So, any questions on this? Okay. All right, clearly you guys are learning a lot of different things today. Okay, now we're moving on to something completely different again. Okay, so this is probably, what, the fourth different thing we've learned today? Okay, so here it is. Okay, we've already talked about this, and we've been doing it all year, right? One way we can write the derivative is dy over dx if we want, right? That means the derivative of y with respect to x. Okay, there's another way we can write the second derivative then. If we're going to use that type of notation for the first derivative, if we want to use a similar notation for the second derivative, we can write it like that. Okay, so we write d squared y over dx squared. That's just the way we write it. But that does not mean we're squaring the first derivative. That means we're taking the second derivative. Is that clear? Okay, so don't confuse that. Don't confuse that with this, because this would mean what? You're taking the first derivative and what? Squaring it. That's not the same as taking the second derivative, is it? No, not even close. Okay, what does this mean? This means you're taking what? The derivative of what? Yeah, that means you're taking the derivative of y squared, right? Doesn't it? And so the only correct way to write second derivative is to write d squared y over dx squared. That's the correct way to write it. Yes? Okay? So just get used to that. Okay, so here we go. All right, again, I'm only doing one of these. This is it. And then you're going to have several of these on the homework tonight, and you're going to have a couple of them on the next test. Okay, so this is the only one like it I'm doing. And so make sure you get it all down, okay, right to the very end. And again, it's write small, or you're not going to be able to fit it there on your sheet. So write really small. Okay, so what does this mean? I want to find the what? Second derivative. Okay, well, before I can find the second derivative, I have to find the first derivative first, right? Okay, and so Danny, the fact that I don't have it in y equals form means I have to do what? How do I find the derivative of this? I have to use what? It's not solved for y, so I have to use what? Very good. You have to use implicit differentiation. Everybody agree? Okay, get this down. Make sure you get this down. So here it goes. So the derivative of that is 4x cubed plus the derivative of that is 4y cubed, but don't I need a dy dx there? Yes? Okay, and then equals, what's the derivative of that? What is it? 0. Okay. Now go ahead and solve for dy dx. And so I'm going to move that to the other side by subtracting it. And then divide both sides by that, right? And trust me, you want to always simplify the first derivative before you continue. So what can I simplify there? The 4s? Okay. Guys, I'm telling you, this is definitely a day where you're going to have your notes on. Like I said, this is the fourth completely different thing I've done, and I still have a couple more different things to do. Very, very jam-packed. Okay, so you're definitely going to have your notes out when you're doing your homework tonight. Okay? All right, so that's the first derivative. Now I got to take the derivative of that to get the second derivative, right? It's harder than it looks, trust me. And so here we go. In fact, I'm going to probably need to go on to a second piece of paper at some point. Okay, so to write the derivative of that, I write d squared y over dx squared. Everybody with me on that? Okay. And then there, I clearly need to use what? Quotient rule. Ready? Here it goes. I take the derivative of the first function times the second function minus in brackets the first function times the derivative of the second function. Whoa. What did I do? Derivative of the first function times the second function minus, yeah, that's right. Minus in brackets the first function times the derivative of the second function. That's right, isn't it? Right? And then all over what?
D squared y.
Yep, sure do. And then all over what? All over what? Yeah, the second one squared. Okay, yeah. Anytime you differentiate a y, right, you have to put a dy dx due to the chain rule. Yes? Yes, go ahead. No, because you're differentiating y's, you put a dy dx. The only reason you put a squared here is because you took the derivative of that, which was already the first derivative. So when you took the derivative of that, you wrote second derivative, right? In this case, you're just taking the derivative of y. So do the chain rule, you got to take the derivative of the inside, which is dy dx, right? It's just derivative of the inside by the chain rule, right? Okay. All right, now clean up this mess. Okay. All right, now, clearly, you don't want to leave that there, do you? And so guess what you're going to replace that with? Any guesses on what you're going to replace that with? Yeah, you're going to go back to here and say, well, I can replace dy dx with that, can I? Doesn't that make sense? Yes or no? Okay, I already found it earlier. I might as well replace it with that. Okay. And now simplify this. Well, those two cancel with two of those, right? And so let me clean this up now. Oops. Actually, that gives you x to the 6, doesn't it? Yes? All over what? Y? Okay, that's a 6. Everybody okay with that? Okay. And then all over y to the 6, right? Good? Okay. All right, now what's wrong with that answer? What's wrong with it? It has a what? This is a what? This makes it a what? Makes this whole thing a complex fraction. You never leave a complex fraction in your answer. So how am I going to fix that? How am I going to clear out the complex fraction? Multiply numerator and denominator by what? By that, and that would get rid of it, right? And so I'm going to have to distribute it here and here, aren't I? Yes? Okay. It gives me y to the fourth, right? This becomes y to the seventh, right? Like I said, I'm going to need to go to a new piece of paper, aren't I? Yes? With me? Okay, so far? Okay, so going to a new piece of paper here. Let me just copy this down. Okay. All right, now you might think you're going to stop there, and maybe sometimes you will, but let's see if there's anything else I can do. What can I pull out of the top, guys? A negative, what else? A 3, and what else? X squared. What does that leave me with? Y to the fourth plus what? X to the what? Fourth, all over what? Y to the seventh. Any questions so far? I'm not done. Any questions so far? Okay, before you box that in, there's one last thing I want all of you to look for, and I want you to go back to the very beginning. Wasn't this the original problem right here? Wasn't it? What do you notice? You can replace x to the fourth plus y to the fourth with what? With 16, can't you? So that's one last thing I want you to do at the end, if you can. Okay, it might not always happen that nicely for you, but if it does, definitely make that substitution to simplify your answer even further. Okay, does that make sense, guys? Yes? Good? So looking at the original problem, I can replace that with 16, giving me this. And I don't think there's anything else I can do, is there? No. I mean, I guess technically you could break that up into y to the fourth times y cubed and then make another substitution, but I don't think I'm going to do that. This will be it. So again, and you'll know where to stop on the test because it'll be multiple choice, right? So you'll know where to stop, right? Got it? On the homework, what are you going to do? You're going to stop wherever Moodle stops, right? Good? Okay, guess what? We're moving on to something completely different again. Again, that was the only one like that I was going to do. All right. Now, what we haven't done yet is we haven't taken derivatives of logarithmic functions, and so that's what's next here. Ready? Okay, so the derivative of the natural log of u is 1 over u, and then by the chain rule you multiply by the derivative of the inside, which will be du over dx. Got it? So again, it's just 1 over u times the derivative of u. That's the derivative for the natural log of u. Okay, and I'm not going to give you that formula. I will not. Okay, I said I would give you the 6 inverse trig derivative formulas, but I will not give you these. These come up too often for me to let you off the hook like that. So you're going to have to memorize these. Okay? Write that down, that you're going to have to memorize those. Okay? Make a note of that you're going to have to memorize those. Okay, so there's the first formula. Okay, now, look at this one. When you take the derivative of log base a of u, technically it starts out exactly like this one. You take 1 over u and then multiply by the derivative of u. Isn't that the same? But then I got to remember to put a natural log of a in the bottom, right? Now, why didn't I do that here? Well, I could have, but what would it be? Well, you can think of natural log isn't natural log of u the same as log base e of u, isn't it? And so if you did put a natural log there, it'd be what? Be what? Natural log of what? E. But what is natural log of e? 1. And so that's why it just doesn't even show up, and you just get that. Does that make sense, guys? So technically, these are the same formula, aren't they? Technically? Aren't they? You all know that, right? That's what natural log is. Natural log is the log base e, isn't it? Okay. So technically, those are the same formula. And by the way, just a little side note on this first formula. If you have an absolute value there to begin with, it doesn't have any effect on the derivative. It's still just 1 over u times the derivative of u. Okay, so that's just a side note. Okay, got it? Okay, let's do some examples. Ready? Okay, so according to the formula, I'm just going to call on you guys and you can help me out here. According to these formulas, what's the derivative? Is that what it? Yeah, derivative natural log of x. What's the derivative natural log of x? It's cool. What would it be here? It's 1 over what? 1 over x times. Yeah, so the 1 over x times the derivative of x. And what's the derivative of x? 1. And so you just get 1 over x. Any questions on that? Not bad, right? Okay, let's look at b. Okay, so hope you can help me here. Okay. First of all, when I take the derivative, what do I take the derivative of first here? The cosine, right? It's a composition, so you start by taking the derivative of the outside. What is the derivative of cosine? Negative sign, and then aren't you supposed to put the inside back in exactly the way it was? And then finish the chain rule by multiplying all that by the derivative of the inside? Okay, now to take the derivative of that, don't you need the new rule that I just showed you? And so what's the derivative of natural log of 5x?
1 over 5x.
And then times the derivative of 5x, which is what? 5. Good. Does that make sense, guys? See what she did? Okay, and by the way, those 5's cancel. And so this is the way I would write the answer. Make sense, guys? Okay. All right, let's look at C. Everybody getting these down? Yes? Okay, so again, isn't this in the form log base a of u? And so just follow the formula. What's the derivative of this? How about, I don't know, Nirek, what do you think?
It would be 1 over natural log of 10
Uh-huh.
times the inside, which is 2x,
Okay.
times the derivative of 2x.
Off to the side, right, which is what?
2.
2. So again, it's just 1 over your u times the derivative of u, and then just don't forget the natural log of whatever your base is also goes in the denominator. Got it? And again, these 2's cancel. And again, this is the way I would write the answer. The reason I put the x out front is so it doesn't get mixed up with that 10. Is that clear? You understand that? Make sense? Okay, last one, then we go to the last page. Let's look at D. Okay, Lauren, you can help me with this one. This is in the form log base 4 of u, isn't it? And so what's the derivative? 1 over ln of 4, yep. And then what else goes in the bottom? That's right, just u, which is cosine of x. And then times off to the side the derivative of the inside, which is what? Yep, negative sign, good. Okay, now here's the way I would write this. Ready? Watch this. I'd write it like this. And then what is sine over cosine? Sine over cosine is what? Tangent, right? And by the way, can I write 4 as 2 squared? And why would I want to do that? Because one of your log properties says when you have a natural log of something to a power, can't you bring down that power out front if you want? Okay, so can I replace that with that? Can I? So you might see that on your answers tonight when you're checking them. So that's what they would have done. And so you might see that as your answer on Moodle. Make sense, guys? So there's a lot of little details you got to watch out for on this stuff. Good? Okay? Yes. Maybe, maybe not. Again, if that answer isn't there, then probably that one that will be. So you'll know where to stop, right? Got it? Okay. All right, last page. Okay, so we got E here. Okay, so any ideas of what I'm going to do here? I don't know. Haley, any idea what I'm going to do here to start? Yeah, good, the product rule. Isn't it the product where both pieces have a variable? And so I must use the product rule. Everybody agree? Okay. All right, so here we go. You take the derivative of the first function, which is x, times the second function, which is just this, and then plus the first function, which is just x, right? And now times the derivative of the second function, which is 1 over 1 minus 2x. Write these down. Write these down. Okay, and then don't forget, if you take 1 over u, don't you have to multiply by the derivative of u? What's the derivative of 1 minus 2x, guys? What is it? Negative 2. Okay, and then just simplify a little bit. I don't think there's a whole lot you can do on this one. I'll probably just write it as this. Okay? So that's the derivative function. Good? Okay, 2 more. All right, now, this one's a little bit trickier. All right, now let's talk about it. If I were to leave it this way, I'd have to take, right, the derivative of the outside, and then when I go to take the derivative of the inside, I have to use the product rule, right? I mean, so you could do it that way, but it's going to be easier if you actually use your log properties from way back in Algebra 2 to rewrite it first before you take the derivative. So before I take the derivative, what's another way I can write natural log of AB? What's another way I can write natural log of AB from Algebra 2? Natural log of AB can be written as what? ln of A plus ln of B, right? And so I'm going to do that. So I can write this as natural log of x squared plus the natural log of e to the x. I can do that, can't I? Yes? And by the way, isn't there another property from Algebra 2 for logs that allow you to bring that down out front if you want? Again, I didn't take the derivative. I did not take the derivative there. All I did is use a natural log property to bring that 2 down. Does that make sense? Yes? Okay, and by the way, there's another log property from Algebra 2 that allows me to rewrite that as just what? X. So again, I have not done any calculus yet, have I? No? Okay, but I'm going to do calculus now. And so here we go. To take the derivative of that, you just leave the 2 alone and say, okay, the derivative of natural log of x is 1 over x times the derivative of x, right? With me? And then plus, what's the derivative of that? What is it? 1. And so you end up with this. And if you want, you can get a common denominator. Yes? Okay? So if you want, you can get a common denominator. If you did get a common denominator, what would it be? 2 plus x over what? X. Does that make sense, guys? If you got a common denominator? Good? Okay. All right, now for f, the good news is you don't have to write it down. I figured I'd type that one up for you since it's so complicated. I didn't want you to have to write all that down while you're trying to listen. So let's take a look at what I did and just follow along. Ready? Okay, first of all, is it okay if I take that and write it like that? Is that the same thing, yes or no? And then isn't there a natural log property from algebra 2 that lets me bring down that 1/3 like that? Right? With me? Okay, and then isn't there a natural log property that lets me write the natural log of a quotient as the natural log of the numerator minus the natural log of the denominator? Everybody remember that one? Yes? So again, I haven't done any calculus yet, have I? Nope. Okay, and then from there, isn't this the natural log of a product? And so I can split that up into what? I can split that up into what? Yeah, into a sum of the natural logs, right? Using another log property from algebra 2, right? The natural log of AB is the natural log of A plus the natural log of B. Okay, and then if I want, I can distribute the 1/3. Again, have I done any calculus yet? Have I done any calculus yet? No, I have not. Okay, well, that's as far as I can go. So now I think I'm going to go ahead and take the derivative of each term. Ready? Here it goes. What's the derivative of that? Isn't that just a number? Isn't 1/3 ln of 3 just some number? What's the derivative of a number or constant? 0. Everybody catch that? Yes? Okay. To take the derivative of that, I just leave the 1/3 alone, and I multiply by the derivative of that, which is 1 over x times the derivative of x. Are you with me? And then same thing here. I just leave the 1/3 alone, and I multiply by the derivative of that, which is 1 over 2x times the derivative of 2x, which is 2. And then simplify, and you get here. I know you get a common denominator, but I'm not going to. Okay, you with me? Good or not? Yeah? Okay, last thing and we're done, believe it or not. Okay. All right, so you already know this, right? That's nothing new. That the first derivative value, f prime of x, at a point tells you the rate at which f is changing at that point, right? Isn't that what a derivative is? Okay, so then the second derivative would tell you what then? The second derivative at a point tells you what? The rate at which what? The rate at which f prime is changing. So you can think of the second derivative as being the what? The rate of the what? The rate of the rate, isn't it? Isn't it? Yes? Okay. Okay, so here we go. All right, so real quick, what's the derivative of that, guys? Help me. What's the derivative? Yep, 12x cubed. What's the derivative of that? What is it? I'm sorry, 12x cubed. Yes, 12x cubed. What's the derivative of that? 36x squared. Okay, so what's f prime of 1 then? If I plug a negative 1 in there, what's f prime of negative 1? Quick. Negative 12. And if I stick a negative 1 in there, what's f double prime of negative 1? Careful, what is it? 36. Okay, now I'm going to use those two values to answer this multiple choice question. Okay, so you think about that and pick one. Talk about it in your groups and pick one. Okay, this is multiple choice. Only one of those 4 statements is true. Pick one. Talk about it in your groups, guys. And then pick one. Only one of those 4 is true. Tell me which one it is. It's a typical AP question right here to make sure you understand the concepts. Okay, being able to find derivatives is just half of what you need to do. You also need to know what it means, right? Don't go taking any absolute values. This is not speed. I'm not asking you about speed. I'm just asking you about what you have in front of you here. So don't go taking any absolute values. Nope, just look at this and pick one. Okay. Which one is it? Which one is it? Everybody agree it's C? Let's talk about that. The fact that f prime is negative tells you what? F is what? F is what? Decreasing. Everybody with me on that? Right? Whenever f prime is negative, the original function f is decreasing, right? And the fact that this is positive tells you what? That f prime is what? F prime is what? What? Increasing. Right? And therefore, f is decreasing but at an increasing rate. Does that make sense? Yes? Are we good on that? Okay. All right.